Hello, here I am. Even though I'm not physically in the room, I'm going to be teaching you guys today. This is the second day of lesson 15.3. So we're going to start with page, where am I here? 697 in your packet. All right, constructing exponential functions from verbal descriptions. So now we're going to take a story problem basically and do what we were doing yesterday. Okay, so just to kind of make sure we're all on the same page and understand what's going on, all right? Let's zoom this in a little bit. Okay, so it says that you can write an exponential function in a different format than what we have been doing the last few days. F of x is equal to a times b to the x power. Okay, and you're like, well, okay, what's a and what's b? A, right? A is the value of the function when x equals 0. So when you guys think of the a position, I want you to think of the y-intercept. Okay, it's the y-intercept. And then b is that common ratio that we have been working with. We've been labeling it R, now we're going to call it B. This is the actual right way, full technical mathematical way of writing an exponential function. Okay, so again, that common ratio is when you take the current value and divide by the previous one. Okay, so let's take a look at what we have here. When a piece of paper is folded in half, the total thickness doubles. So the thickness doubles. Suppose an unfolded piece of paper is 0.1 of a millimeter thick. All right, the total thickness T sub n, or T of n, excuse me, of the paper is an exponential function of the number of folds, n. So the value of A is the original thickness, right? The original thickness. Well, we were told the original thickness was 0.1 of a millimeter, right? So this is our A. A is equal to 0.1 of a millimeter. And then we were told that, of course, as you fold paper, it gets double thickness every time. So that means our B, right, is 2. So then what you would do is you're going to put it into the equation, right, that says A times B to the x power. Okay, A times B to the x power. So you drop them into the appropriate spots. We know that A was 0.1, B is 2 to the x power. All right, easy enough, piece of cake. Let's take a look at example 2B. Next page. A savings account with an initial balance of $1,000, right? The initial balance of $1,000 earns 1% interest per month. That means the account grows by a factor of 1.01. So let's make sure we understand. You have 100% of your money plus the 1% interest gives you 101%. Change your percent to a decimal, and that's where they got the 101. Okay, so each month, if no deposits or withdrawals are made, right? So your parents put $1,000 into this account, you get 1% interest, and they started it the day you were born, and you have not added a lick of money since. It's just been sitting in the bank. You don't even know it's there, right? So the original balance, the starting price, your parents put in $1,000. They were very nice. And then we know that it's going to change by 1.01. That is our B value. So we're going to remember that we're going to drop it in A times B to the x power. A times B to the x power. A is 1,000. B is 1.01 to the x power. Okay, so I want you guys to answer the letter, or number 5, excuse. Why is the exponential function in the paper folding example, example A, why is it discrete? So go ahead and hit pause here and take a minute or two to write down why is it discrete. So I wrote down my answer here. I said folding paper is discrete because there can only be whole number of folds. You can't have a half a fold. You can't be halfway through a fold. It's either a fold or it's not a fold. All right, I also would like you guys to take a moment and figure out the equation for number 6. All right, this is your turn. So again, let's hit pause and solve 6. So because our paper now is 0.2 millimeters thick, it's a little bit thicker paper, but we are still doing folds, and folds are still going to be doubling. So T of n is equal to 0.2, which is our A, times 2, which is our B, to the n power. All right? If you need to, let's discuss it. Otherwise, keep on going. So let's take a look at example 3, constructing exponential functions from inputs and output pairs. So now it's not necessarily going to be a story problem, but we're only going to be given 2 pieces of data and we're going to have to calculate everything. All right, so this time we are not given A, nor are we given the B. We're going to have to go find them. So I have given the point 312 and the point 424. And I want you to notice that 312 and 424, if I graphed them, would be next to each other, right? 3 and 4 are next to each other on my inputs, my x's, and my outputs then are obviously whatever we did to it. So we can find our R value, okay? We can find B by taking the 24 and divide by 12, right? We're going to take the current number and divide by that, so we get 2. So that is how they got that B was equal to 2, right? R and B are the same values. Well, we don't have A. We're going to have to go find it. So what we can do is we can plug one of these 2 points, right, either 312 or 424, into the function. So I'm going to choose to plug in 312. Okay, I'm going to choose to plug in 312. I could easily put 424 in. It's not an issue. So I'm going to take 312 and I'm going to drop that in. So the 12 goes into the X, the answer, the output, and the 3 goes into the exponent. Oop, go down there to the exponent. Okay, so if you have a highlighter, you could highlight those in 2 different colors or just draw the arrows like I did. All right, so now we know that 2 cubed is 2 times 2 times 2. I had you all memorize that. We know that that is 8. So that is how we got the 8. Divide both sides by 8. And 12 divided by 8 is 3 over 2. Yes, leave it as the fraction. Fractions are your friends. So our final answer, so now we know that A is 3 over 2, and we know that B is 2. We take both of these, drop them into the equation, and we have 3 over 2 times 2 to the x power. All right, we could do it another way if you wanted. You could do it another way. You could make a table. All right, and we could keep track of 0, 1, 2, 3, 4. We can put in the 4. We know that was 24, and we know that 3 was 12. Okay, so you could find your common ratio this way, right? 24 divided by 12, and you get 2. And then you could just work backwards. 12 divided by 2 is 6. 6 divided by 2 is 3. 3 divided by 2 is 3 over 2. And that's how you could also find the A value. All right, and here's your B value. So you can work it backwards and just, but if this is way down the list, that's going to take a long time. The equation way is a lot easier, but it is a second way to do it. All right, so let's try part B. All right, let's take a look at B. So we have the point 1, 3, and the point 2 and 9/4. So first thing we're going to do is find the B value. We're going to find what is our common ratio, right? So 9/4 divided by 3, right? 9/4 divided by 3 actually becomes 3/4. So now we have our ratio. So we're going to write the general form just to kind of make sure we know what's going on. F of x is equal to A times B to the x power. Well, we'll substitute in our 3/4, our ratio, 3/4. Now we get to pick which one of those up at the top we want to work with. I'm going to choose to work with 1, 3. Don't have to. You could pick 2 and 9/4, but that's got a fraction, and I know how much you guys love those. So we'll go here. All right, so 3 is my output, and my x value is 1. So I'm going to fill those in. Well, 3/4 of the first value is pretty easy to work with, right? So 3 is equal to A times 3/4. So in order to get rid of the 3/4, I'm going to multiply both sides by its reciprocal, 4/3. Multiply by the reciprocal, 4/3. And so when I do that, I find out that A is 4. Easy. So now I have my A value. I have the B value from up here, right? And I'm going to put them together and make my equation. So my equation is f of x is equal to 4 times 3/4 to the x power. Okay? So I'm going to ask you guys at this time to try number 7. Hit pause. Give number 7 a shot. Ask someone near you if they got the same answer, and then go ahead and hit play and see if you match mine. All right, so my B value I found to be 5. My A value I got to be 10. So my function is f of x is equal to 10 times 5 to the x power. Okay, how'd you do? So I wanted to kind of quick look at number 8 here if we've still got time. If you're running out of time in class, you can go ahead and stop. If not, let's keep going. So it says, explain why the following statement is true. For 0 is less than b, which is less than 1, and a is greater than 0, the function f of x is equal to a times b to the x power decreases as x increases. Why is that true? Okay, why is that true? So I want you to think about, what are we talking about? What kind of b values are we talking about with it being between 0 and 1? So pause here a second, think about it. So I know that b, because it's between 0 and 1, must be a fraction. All right, and then the a value we know is just got to be something bigger than 0. It can't be a negative. And but it's the key that we need to know is that b is a fraction. So if I multiply by a fraction, I know my answers will get smaller. So the answers, the output, will get smaller. So again, if you still have time, go ahead and answer number 9. Explain why this statement is true. So for b is greater than 1, and a is of course greater than 0, why does it increase? Okay, I'm going to hit pause here a second. So b is a number greater than 1, so when you multiply by anything bigger than 1, you know your answer is going to get bigger, right? All right, so you guys do have an assignment. Yay! You have an assignment for the weekend. You are going to do, here we go. I need you guys to do the following problems. Numbers 4, 5, 7. Oh, nope, I apologize. Erase that. I'm looking on the wrong day. It's much easier than that. You guys are going to do problems 5 through 18. I know it sounds like a lot, but you guys can handle it. You're big kids and you have a whole weekend to do it. You guys are going to do problems 5 through 18. See you all on Monday.